Awesome. I can see some people still coming in. So thank you so much for coming for this talk. It's the first time I'm presenting this subject, so, well, and I intend to show a lot of code, so some stuff might break, so I hope you stay here with me. And for the brave that stay until the end, I brought some goodies that I intend to raffle with you. So if you're here in the end of the session, you might win either a Pixel Buds Pro or Google Nest Audio. Okay, and I hope you enjoy it because they're heavy. Well, at least the speaker is very heavy, and it was had some trouble bringing it from the US to you. But I hope you enjoy later. Okay. And before we start, let me ask, how many of you have Android phones? Okay. How many of you added the Google Wallet Pass to your phones to come here today? Okay, we can do better. Also, for the next event, when you receive the email with the tickets and everything else, you're going to open your email. Actually, let me try to find it. You're going to open your mail, and you're going to see a big button called Add to Google Wallet. Okay, and you're going to click that and add to your phone because it makes your life so much easier and makes the registration queue also much shorter. So I think it's a big improvement for all of you. And why I'm saying this? Because, well, my name is Edson Yanaga. I'm a developer relations engineer, and I'm responsible for Google Wallet. So, shameless plug. So you should be adding your wallet passes to your Google Wallet. And for those of you that have Android phones that didn't download the Google Wallet app yet, well, you still have 30 seconds to do that before we start the session. And today's talk is revisiting design patterns after 20. Why I took 20, and actually some people ask me, why isn't it Java 20? Yes, but because I'm very bad at puns, I thought, well, it has been more than 20 years since the original design patterns book, 1994. And 22, because Java 20 is right around the corner, is going to be launched next week, next Tuesday. So some of us might be ready to try some of the latest and greatest features. And I also like to point out when I proposed this talk, when I had this idea, I proposed this talk, when I was preparing this material. 2 weeks ago, I was doing some kind of research, and I found a great talk by Mario Fusco. I know he's here in the conference, and he's here. He's here now, but also he delivered a talk with similar ideas 6 years ago. And of course, some stuff's changed in the past 6 years, but if you haven't watched it yet, I recommend you because great content. And actually, some of the ideas are similar to what I'm going to present today. Some are not. So, but it's good to have like diverging opinions, and also it's good to see that there are some patterns that repeat between different projects and different developers, and that's why we're discussing design patterns today. So as I mentioned, the original idea from design patterns came from this book. Actually, design patterns came from an architecture concept, and some other patterns that followed. We can find some patterns in the domain-driven design book. Actually, I picked one to show you today. And of course, even though they don't call it patterns, there are some best practices that are presented in the Effective Java book. So we just mixed all of these best practices together that we collected from the past 20 years and tried to show you how can we do differently. I'm assuming that some of you will see familiar code. Well, I'm already doing this in my production code, which can be good if we can agree that it's a good pattern. Or it can be bad if you agree that it's an anti-pattern. So let's see what's our conclusion in the end. And as I mentioned, Java 20, there's going to be an event to announce Java 20 next Tuesday, March 21st. And I'm going to show a few features that are available in Java 20. And I hope we can all enjoy the new feature of the Java language as Java developers. I know some of you are not Java developers, but at least you can be jealous or sorry for the state of the Java language. Okay. So what is a design pattern? I emphasize here some words. A design pattern is a general, reusable solution to a commonly occurring problem with a given context. And when it says a general solution, it means that design patterns can be copy-pasted between projects because they need to be applied to a specific context, depending on the problem that you have. And we're saying solution, problem, and context means that in some context, this design pattern might be an anti-pattern. In other contexts, it might be a good solution to the problem. And it's up to us, developers, to decide if it's a good or a bad solution. And design patterns also allow us to create a pattern language. So 20 plus years ago, when we had the book design patterns, I'm pretty sure that a lot of developers had reached the same solution, but they never knew what was it called. So I'm pretty sure that a lot of developers 25 plus years ago, they implemented the strategy pattern, but they never named it strategy pattern. A lot of them implemented template methods, a lot of them implemented abstract factories, but they didn't have a name. So today, more than 25 years later, when somebody says, oh, you need to implement a strategy because maybe that's the best solution for this particular problem, nobody needs to explain what is in a strategy pattern because we already have a pattern language. We already know what is the strategy, and we can talk to other developers just proposing the solution instead of having to explain why the design pattern, why strategy is a good solution, how do you implement that. No, they just say, well, here we should be implementing an interpreter. Here it should be a command. Here it should be an observer. So we have a common pattern language. So that's a good thing because it improves the discussions around code design. And some of the guiding principles that I took to be presenting the solutions today, of course, I got from other authors, and I'm going to present the 3 major principles that I chose to for the solutions. First, favor composition over inheritance is from the original design patterns book. So instead of trying to do inheritance for most of the stuff, try composition. Favor is smaller interfaces. Some people know these principles as the interface segregation principle, which was presented in one book. And yeah, you know which one I'm talking about. So in one book, and it was reused with other names in other books as well. And also, I took this one from Effective Java, favor existing interfaces. So if you're thinking about creating an interface, and well, first you should try to look at the source code of the JDK, well, to see if you don't have a similar interface in the JDK, and instead of creating one for yourself, try to reuse one that already exists. And why should we be doing that? Well, again, because of a common language. So if you create my own interface and declare one method, well, instead of doing that, instead of reusing a function, Java O2 function, instead of using that, I have to explain to people, what does my interface do? What is the purpose of my method? But instead, if I reuse function, if I reuse consumer, if I reuse a binary operator, you don't have to explain to people what your interface does because everybody is already familiar with the concept. So try to favor and reuse existing interfaces. And before we move to more code, more slides, actually, let me go through some code. I'm going to start with the obvious ones so we can dig to some interesting ones. First, if you create a strategy pattern, which I'm pretty sure most of you are very familiar with this one. The classic way for us to implement that, for example, here, suppose that I have a REST endpoint, and I have different strategies to generate the Add to Google Wallet links, okay? Another shameless plug for me. So if you know about the Google Wallet API, you know that there are 2 different ways for you to create the link. You can create a complete JOT. Everybody is using JOT these days, and with Google Wallet it's not different. So you can have a big JOT that contains all the information, or you can pre-create the information and just reference the information in the JOT that you're sending to the user. So it really depends on the use case, how much traffic do you want, or if you want to pre-create the information before sending to the user. So we have 2 different ways of doing the same thing of achieving the same result. Clearly is a strategy. So the classical way is I create an interface. I'm creating my own methods, which is receiving a pass information and returning a string. And I have here two different implementations, which is very complex, as you can see. A JWT, a JOT with complete information, and another one with just the IDs of the objects, okay? This is the classical way of implementing that. If I'd like to do it in a different way, what I would do, well, the code looks very similar. What did you change? Well, instead of creating my own interface, and I know it's up to discussion, I could have just declared here, instead of creating an interface and extending function, because it's similar, what I'm doing here, I'm just getting the generics and forcing a type to them. I'm creating my own interface. Advantage, I give a name to the stuff I'm creating, add to Google Wallet strategy. Downside, I'm creating an additional interface. It's an additional context that developers of my system, of my code, will have to learn about it. So I'm not certain what is the best practice here, but, well, you could be doing this, or instead of adding this add to Google strategy, you could have just replaced here a function that receives a pass information and returns a string. Okay? Both works. You can see that the code still compiles, so no big deal. And remember, whenever you have this kind of interface, remember, favor smaller interfaces. I could even improve this statement. Instead of favor smaller interfaces, maybe not only favor smaller ones, favor function interfaces, the ones that you can use in lambdas. And you could be replacing this, instead of just set strategy, you just be creating your lambda here, a pass, and returning a string. Okay? That's reasonable. You could be doing that in your code as well. So this is the obvious one. What else can we do? Let's move to another one, which is legacy template methods. A lot of us certainly have implemented some business logic in our code where you have like pieces that are repeated and pieces that are different in our code. So the natural way for us to implement this kind of code is to create, for example, I have here a class, Google Wallet Pass Creator, because I have different types of passes that I can create. For example, I can create a loyalty card, I can create an event ticket, just the one that you received here in your DevOps registration, and I have the same steps for each type of pass. I need to authenticate with the API to be able to generate a pass. And once I created my pass, I need to sign the JOT with my private key to be able to send this link to the users. So the first step and the last step are always the same. What changes is the type of pass that I'm creating. So what I created here, I created an abstract class with an abstract method, do create, just like in the book. Do something and do something and this protected abstract methods is implemented in one of those subclasses. Okay, this is the legacy way. In the revisited way of doing that, we can take this piece of code from Effective Java. Instead of creating an abstract class, I replaced template methods with what? With strategy. So instead of creating an abstract method that needs to implement it in subclasses, I just create a class that in its constructor is going to receive a function. Again, that is a function, consumer, producer, whatever is your need. I'm just getting a function here because that's what we do most of the time. We get an input and we transform that to an output. So we get a function here that is a property of our class, and we just invoke that particular strategy that we have and apply with the information that we have. So no more subclasses, just one single class. And when we're instantiating the pass creator here, I can give here the implementation that I want. Or if your implementation is not a one-liner, what you can do, you can implement another class, and you can, in your Lambda here, you can reference the method in another class, or even better, if you have the same parameters, you have the same method signature, you can even use a method reference, which is the preferred way if your interfaces do match, if your parameters do match, okay? These are the two most obvious ones. And now I would like to create a parenthesis for a discussion. Oh, just realized I have more. So I'd like to open a brief discussion about why are we evolving our code and why we're changing this. 30 years ago, we had structured programming. So we had points with two properties, x and y. I don't even remember if we called like properties. We called something else probably. And we would implement a methods, do something, and because these methods were supposedly stateless, we would have to, for everything that we did in our structured system, we would need to pass the state of the system, in this particular case, P, point P, and another contextual information, another parameter saying what do we want to do with that particular state. And we would code it. And when we were calling this code, we would say, do something, pass the parameter P, and the amount that we wanted to change. When we changed it to object-oriented programming, we created, instead of a struct, we created a point. In Java 20, we could be saying it's a record. We would implement do something and the amount. And to invoke this particular code, we would do p.doSomething5. What changed here? State, instead of being something external to our code, now state can be embedded in the type that we're calling. We call that encapsulation, and a lot of people would argue that it's the greatest benefit of object-oriented programming, that we can control, we can tame the state of our system by having smaller encapsulated contexts. Okay, and if you look at how we design programming languages, p.doSomething5, if you take the legacy code, structured programming, and we take the object-oriented code, now, what changed? Well, what changed is that I had the name of the method, or the name of the function here, and I had the type being passed here as a parameter. And in object-oriented code, I have the type first, and then I have the name of the methods that I'm calling. So from the point of view that what you're typing, that's the only thing that changed. A lot of things have changed behind the scene, but from the code you're typing, that's the major difference. Behind the scene, what's happening? Well, when your code is being executed and your environment needs to decide what instructions are going to be executed by your computer, it's going to check here. I want to execute the code related to this particular name that has this particular type as a parameter. In object-oriented languages, first you choose the type and you decide which kind of code from that particular type is going to be executed. Right? We call it single dispatch. Single dispatch means that the instructions that your code is going to that your computer is going to execute depends only on the type that you're referring to. So if I have here do something and it's point P, I'm going to execute this particular code from these methods. If my type P, if my type point if that's my type, I'm going to be calling this particular method from that particular class, which is my desired implementation. This is single dispatch. So what we've seen so far, strategy is a single dispatch decision. The method, the code that I'm going to execute depends only on one type. And I'm going to show you how does it work for double dispatch. Moving back to the IDE. That's why I'm going to show my favorite legacy pattern, visitor. I don't know how many of you implemented visitor before, but I read that in the book, and I was always wondering, when I was very young, of course, I wanted to prove myself. I want to show to other people that I was smart, I knew how to code, and all that kind of stuff. And the visitor, by far, for me, was the most complicated one to first understand, a second, to find a good reason to implement it. So sometimes developers, we try to create problems so we can solve them ourselves. And we can brag that in the next stage. You see how I solved that particular problem? Well, I created it and I solved it. So we have a visitor. Visitor is a pattern that uses double dispatch. What kind of problem does it solve? It solves because the code that you want to execute depends on both on the type that you're calling and the type that is being called. So you have two different types to decide on which operation is going to be executed. And how do you implement that? I'll give you an example, just like I had here. Remember with in our domain model, Google Wallet has different types of passes. You can have wallet, loyalty, event tickets, and others. Also, there are two different ways of generating your passes. You can generate that as a complete jot or as a brief jot. Big one, small one, each one depends. There's no best solution. Each one depends on the occasion. So I have a strategy here. Well, I have two different ways of creating. I can create a loyalty or I can create an event ticket. And I have here another decision. I can create a complete one or a pre-created one. I have two different options. How would you do that? Well, you can create a lot of ifs in your code. You can start adding instance offs in your code. But every time you add an instance off, or every time you have like a lot of ifs that you're questioning the type in which you're applying an operation, maybe that's a bad practice. So what you can do? Well, when you have this problem that you have different operations applied to different types of objects that you want, that's a use case for a visitor. So how do you implement a visitor? It can be complicated to read because the visitor here, you have an interface called visit, and you add here the parameters types. But basically, on your hierarchy, you create an abstract class, in this case a pass. You create this method, which doesn't mean much, accepts a visitor. And in each one of those subclasses, you're going to implement this, visitor.visit, and you add the type. Okay? And when you're generating the code for you to be calling that particular visitor, well, I have here, I'm going to create a new loyalty card. Okay? And because I have a loyalty card, I can even say that the type here is going to be Google Wallet Pass. And this card, I want to create a complete jot. Well, you just create a new visitor that is going to return, it could be a string. And here you're going to implement the code for loyalty cards, and here you're going to implement the code for event tickets. And then if you have the use case, I want to create the reduced version of the jot, the brief jot, you're going to create another visitor. And very likely, you won't be doing this inner class. You would be creating a separate class to do that. Well, why should I be doing this visitor? Because code is more readable and more maintainable when related objects and operations are kept closer to each other. That's why we would be implementing a visitor. And very likely, some of the operations are similar between the brief jot and between the complete jot. So our visitor could be having a template method, or even better, another strategy. So you can mix and match multiple different types of patterns in once. But you also might argue that this code is complicated. But I can see one benefit here. When you implement visitor, whenever you create another concrete class of your code, if I create here, for example, a generic pass, and extends Google Wallet class, and I implement it, whenever you create a new concrete implementation of your abstract class, all your visitors automatically break because you need to add another implementation. You need to add another method here to visit, which is going to be generic pass. And you have to implement in each one of those visitors that you have in your code. So the benefit of it is that whenever you change the hierarchy of your classes, your visitors break at compile time. There's no way that you forgot to implement something that is not to cover that particular case that you just created. For me, it's a benefit. Okay, so you don't have runtime errors. You have compile time errors. And what is the modern way of implementing visitors? Well, What do we do here? Instead of implementing that very complex stuff, now with Java 20, we have pattern matching. And instead of having to create a separate class for the visitor with all those accept methods, you can just use pattern matching for the particular types. So if I create here a new Google Wallet pass here, oh, and I remember I forgot to copy my classes here. Let me quickly copy and, copy and paste these classes here. If I create these ones and visit here, better to create again. Okay, sorry for this one. So if I have a class, an abstract class, Google Wallet Pass, and I have these ones, class loyalty extends Google Wallet Pass, and have a class event ticket. Okay, and I have these ones. I create a new loyalty, and the type is Google Wallet Pass. Of course, this one I know the type, but suppose you're receiving that as a parameter or somebody set that in your code as a property. What you can do is you can switch on the pass, and you can say, well, case, well, if it's a loyalty. You can even use a lambda and do something. Let's see. Let me create another method we return. Int, do something. And I receive a Google Wallet Pass parameter. I think it's a better example. And if I switch on the type of parameter, I can say, well, this one I can return 1. Okay. And actually needs to be 1. Case loyalty. What am I missing? Return, yeah. Case event ticket. E should be 2, and this go on. Okay. Why is it complaining? Because the switch is not exhaustive. Because somebody can get here and add another subclass of Google Wallet Pass, and my code would break, which means I would probably, most people would just implement a default one and throw new runtime exception you forgot to implement. The problem is that this is an error that you only learn like 2 months later when you have this particular use case. Oh, somebody forgot to implement that you have a new type in your system. Luckily, with Java 20, what you can do, you can use sealed classes. So if you create here a sealed class, Google Wallet Pass, and you permit loyalty, and you permit event ticket, and you make it final, right? Now your code should work. I tested this before. Yeah.
Google Wallet Pass and interface.
Interface.
Yeah. Because it can be a Google Wallet Pass itself. It's like
Oh, okay. Perfect. Thank you. Oh, now implement. So nice when you're like doing live demos with people smarter than you. Yeah. So return switch pass, and with Java 20, what we can try if you get a release candidate or after Tuesday, what you could try is that here you have this, you're implementing the same thing that you could do with a visitor. Now you're implementing here with code. You don't have all of that boilerplate code that you need to extend, accept, no more visitor. You can switch based on the type here. And with Java 20, another benefit is that here We're choosing the code that we're going to execute based on the type of the objects and the type of the pass. So the strategy is here. I want to create in two different ways, and I have different types in which I can decide which operation I'm going to apply. With Java 20, we have a new feature of the pair matching that we can decide the operation not only on the type on the double dispatching thing, but we can also decide on the state of the second parameter. Suppose here that at our loyalty class, it had a property. Suppose that I had a property, and with loyalty, well, loyalty L, and when the amount, did I mention amount? Size. Well, dot size is bigger than 10. I want to return 1. Okay? And when case loyalty L, when L dot size bigger than 20, well, it should be 2 as well. And, well, now it doesn't compile. And why is that? Because I didn't cover all the cases. You have a compile time error. And if you want to be complete, you need to say, well, case loyalty, when it didn't match any other ones, then it still should be 3 or something. Okay? Then your code compiles. Now you can implement the same thing as the visitor did. You can do double dispatching, but you have another benefit that you can also query some properties of the object that you're trying to refer to, and decide if you have other types of operation that you want to do or not. I think it's very beautiful, especially when you're trying to implement visitor. Okay? This is the most complicated one. I admit that very few times in my career I had to implement a visitor, but if you ever implement a visitor, you know that when you need one, you do need one. What else? Let's move a bit to the obvious ones. This one, you've seen this before many times. You can have a singleton. A legacy one, you would create a private static final property, create one. You can do lazy initialization or not, but if you don't, well, you just create here and static legacy singleton return instance, you do that. Okay? This is the legacy one. The new one, you just use an enum, okay? Which is by far one of my favorite features. What else can we do? We can also try, for example, a chain of responsibility. The legacy one, the chain, you get straight from the design patterns book. You have created, for example, a user notifier based on a user profile. For example, a profile, I just created a record with some properties. For example, if the user has a wallet pass in their phone, if they allow email notifications, or if they allow you to send an SMS. So if you go to the legacy chain, I created a notifier interface, and now I turn it on, I don't know how to turn it off. You can see that I changed everything today.
Right-click it and just go.
Right-click? Yeah. Close. Thank you. You see, smart people. You get legacy chain of responsibility. You create here interface notifier with 2 methods. Notify and set the next one because it's a chain. Then you have to create an abstract one which knows the next one. And when you're implementing one, for example, if you want to send a pass update to your Google Wallet, you have to do this boilerplate code. You have to check if the user has enabled this kind of notifications, and if they did, you do something, or else you call the next notifier in the chain. Boring, right? The problem with this implementation is that maybe your code is doing too much. You're doing first, you're testing if your object in the chain applies, and then you're trying to do the thing that you're supposed to do, and then you have to follow the next object in the chain. What can we do different here in 2023? Well, there are different ways of implementing that. For example, I could have created a class that implemented both the predicate and the consumer and use that in a lambda. Another option, just because I wanted to use a record in an example. And I think it was a good opportunity to do that. So I just created a record with two properties, a predicate and a consumer. And both are being applied to a user profile. So I want to test if I can apply this to a particular user profile. Predicate returns true or false. And I have a consumer because if it does apply, I want to consume the information on that particular consumer. Okay. And what can I do here? And actually, after I did that, you can see here that I also use the alternate implementation. I have a Google Wallet pass notifier. I can implement consumer. I can implement the predicate and implement both methods. I'm not convinced in which one is better. I think it's up to discussion. It really depends. As for now, my opinion is that really depends on your personal choice. But separating these two operations, the test if it applies to that particular profile, and the operation that you're applying to the profile, for me, at least for now, is the only winning point that I have for this particular pattern. And once you did that, if you have a user profile and you create a stream of the chain links that you have, for example, new Google Wallet pass update notifier, and you have other implementations here in the chain, it's just a matter of filtering and .test user profile. If it applies, then you find the first one that applies to your particular chain, and if present, because in our particular case, the way implemented, if you don't have any notifiers, well, you just don't notify the user. Some people prefer not to be aware. Then you say, and .accept user profile. And if it's not present, well, maybe you can even throw an exception. It really depends on how you want to code it. Okay? So you can use a record. You can implement both methods, both interface in the same class. I don't judge. I think both of them work for you. And what else can we do here? Specification. Specification, this one I took from domain-driven design. Okay. And you might, I don't know how many of you implemented that. Usually when we're creating repositories for our code to query databases or the kind of data, it's very common for us to create specifications. And this one I used like quite a few times in my career because when you're creating a query to your database or when you're trying to see if, well, does my set of like objects of users, my domain objects, do they match a certain criteria? It's very common for us to be creating those SQL queries or to be creating our big if statements with a lot of Boolean statements in between. And it's just that. We just have those expressions, but we don't assign a meaning to our code. So a lot of times, I would be creating these specifications myself, or I would be using, for example, I don't know how many of you use QRDSL in the past. I use some of you. Well, QRDSL, they have a specification built in. You can create and compose based on that. And when it's running, and it tries to run your database query, it's going to convert your specification into a SQL query or a JPA query. It depends on how you're going to implement that. So that's another benefit of specification. You can translate that to multiple different types of query languages. So look at that. So what I could do, I could get a string, for example, and I could write a statement like this. If s.length equals to 16 and s.matches this particular regular expression. And when you're coding it, it makes sense. 2 weeks later, you have no idea why you typed 16. It's a magic number. You don't have no idea why you created this regular expression because nobody gave a name. And you might be doing even better. You could be doing better. You could be assigning this to a Boolean variable, saying, well, this is if the number is greater than 16. Well, it doesn't help much. But what else could you do? Well, you could be giving names. You could be using a type that is composable. And that you can use this particular implementation as a strategy for multiple different types of queries later. So how would you create a specification 10 years ago? Well, I would create an interface. I would create a method, Boolean, is satisfied by. I would pass a string. Then I would create here, I use the advantage of default methods and interfaces. And I create, well, if you have an end, you can create a new end specification. I implement new or specification and new not specification. And just the other one. Okay? So I created and I implemented this records and specification or specification and not specification. And I also implemented here not or and end. And very likely in the future, I would have to implement here. How do you translate this to SQL? How do you translate this to GraphQL? Or how do you implement this in other stuff? And why I created here? Well, you can see here that clearly this thing is a predicate. It gets a parameter and returns true or false. So what I'm doing here, I'm creating a specification. Is it the right length? And I test if it's 16. And then I have another specification, is numeric, and I have s.matches. It's only digits. And then I create another specification. Well, is it a potential credit card number? And is it the right length? And is numeric? So that's how you would implement that using a specification 10 years ago. And why would you do that? Isn't it simpler to just write in one stuff? Maybe, but once you create your first specifications, what we also did in the past, what can you do? You see that in your system, it's very common for you to be constantly reusing the same queries across your system. For example, every time we would create a query, we would say, well, is the account still enabled in your system, or does the user have permission to be doing that? And you would be reusing the same query all over the place. And you would be concatenating the same steps in your SQL query every time you type any kind of query. So why not create a repository when you can store all your specifications and keep reusing them? So that's one of the benefits of using specifications. For 2020, you don't have to implement specifications anymore because you have built-in the JDK, guess what? And a specification. So instead of creating all of that code, and actually the benefit here is the predicate in the JDK, it is complete because it only I implement only 3 operations. Here you have much more. So instead of creating my own implementation of specification, I'm just reusing a predicate, which is the very similar code, achieves a similar result with the added benefit of having much more operations. You have negate or not and others. Okay? And we're almost out of time. And before we finish here, I'd like to ask you if you have any questions for me, besides suggestions on how to better use the IDE. No? So if you enjoyed this, I'm sharing this code on my GitHub. Yanaga revisiting design patterns. I have these particular ones. There are others that I want to contribute. As I mentioned at the beginning of the talk, I watched a talk 2 weeks ago from Mario Fusco talking about the same subjects, and you have great ideas over there. I recommend you to be watching that talk as well. And before we move to the Raffle, another shameless plug. If you're interested in Google Wallets, just visit developers.google.com/wallets. And because I know you're interested and during the talk you added your event ticket to your Google Wallets, if you have an Android phone, I like to perform a raffle. Okay? And because I wanted everybody to win, even people that doesn't have the best digital wallets on the planet, we're going to be creating different. I'm not going to be super specific. You need the Google Wallet, so we're going to do this. We have how many rows here in the theater? 1, 2, 3, 4, 5, 6, 7, 8, 15. 15 for the people that are standing in the back. Okay? So I have 15 rows, and I have how many seats here? 21. I should have counted before. So 15 rows, each one has 21 seats at most. And if we don't have anybody seated, we're going to get the closest person, or do we raffle again? Raffle again? Okay. Now we just need a random number generator. Okay. Should we implement one? Nah, we already have a solution for that. We can type random number between 1 and 15. So I'm going to raffle. Which one I raffle first? The Pixel Buds Pro or the Nest Audio? Whatever. Yeah, I'm going to raffle the big one. And it's also the least expensive one. Okay? It's big, it's heavy. It gave me a lot of trouble to bring it. And it costs half the price of the other one. So first, the row, random number between 1 and 15. 9. So who is on the 9th row? 1, 2, 3, 4, 5, 6, 7. How do I say it? Yeah. You gotta get assistance. Ninth row? Okay. I suppose it is. Yeah, you can see. And now, random number between 1 and 21. And we're going to count that from my right to the left. Okay? Generate the number. 1. Does this have numbers? Oh, gosh. What is the last seat?
It's there.
No, but what is the number of the seat? Yeah.
Gotta be 21.
Oh, it's numbered on the row.
Yes.
Oh, okay, not total. So you see the number in your seat? Between 1 and 21 and 22, sorry. If you're number 18, I'm sorry. 16. Anybody seated? You can't move. Okay. No. 16? Congratulations. You can come, and while you're getting downstairs, we're going to raffle the second one. So we have 15 rows. Yes. So it's a bit biased, okay? 4. See number 4? Congratulations. Thank you so much. Thank you so much. I hope you enjoyed. I hope you forgive me. And, well, thank you for being here. Thank you, Vox Direct. And I hope you have a great rest of your day.
Thank you very much.
Thank you. Congratulations.